Hi, my name is Brian Alvarez, and today we're going to present OPAM parameters. First of all, we're going to divide. First of all, we can think in an OPAM that is like a tiny powerhouse that can amplify, invert, filter, and perform various mathematical operations and electrical signals that can be converted. This is the magic of a operation amplifier. It's a versatile integrated circuit found in a countless electronic devices. For this part, we're going to show the diagram of the amplifier that we use, that is the LM741. First, we have 8 pins, in which we have in 4 pin B negative, that is the negative limitation of the op-amp. In the 7, we have B positive, that is the positive limitation of the op-amp. In op-amp functions, we have variety of these, that is amplification, inverting, filtering, and also we can use this that mathematical operations that they can perform basic signals like adding, subtracting, integrating, and differentiating. This is useful for analog to digital conversion in signal process. We're going to explain the live applications that we have day or day with an op-amp. The first we have is audio equipment, that the function of the op-amp is amplify the signal to make the loud sound of a speaker. In medical, we have the sensory measurements like electrocardiogram, that it makes like the signal of the heart to be shown in a monitor on other devices. Another, we have sensors and measurements, that is when it's cold, they receive a signal and they amplify to show the best way in the device. And also in the cell phones, computers, we see these op-amps. Um, in this part, we're going to explain the parameters that we are going to use in the op-amp. This is function because we are going to see part and part what is the importance of this op-amp and how these things are in when you use all, we can get the functions of daily things that we use. We're going to start explaining the offset that can be compared with the balance because it's imagine that you have a perfect balance scale. Ideally, it should rest perfectly centered when empty, but in reality, there might be a slight imbalance constant until in one duration. Similarly, it happens in op-amps. Can have an offset voltage, a small voltage, and its output even when its inputs are the same level. This offset can arise due to the component mismaking with the op-amps. Understanding and minimizing offset is crucial for achieving a perfect amplification. In this part, we're going to talk about the power consumption and supply current. Op-amps need energy to operate just like any device. Their power consumption is measured in milliwatts and indicates the amount of energy they draw from the power supply. This is important for battery power applications where conserving energy is a critical. The supply current specifies the current draw for each power supply rate. Lowering power consumption and supply current can extend battery life and reduce generation. For this op-amp, that is the LM741, we have a maximum voltage supply of 22 voltage, and the consumption have 85 milliwatts. It varies about the model that we can about. It is 731A and 71C that we can see here. The changes are notable in each version of the amplifier. We are going to talk about CMR, that is the common mode reading ratio. That to explain what it is like you imagine that you have two speakers playing the same music at slightly different volumes. The difference defines the desired signal, but the overall volume represents white noise. Similarly, op-amps can be affected by common mode signals. Voltage applied simultaneously to both inputs. The CMR tells us how good is the op-amp to reject these common mode signals and amplifying the only desired different signals. To explain how it functions mathematically, we can to see the first two formulas that we have upstairs. That is signal differential and signal common. The first formula is going to give us the basic CMR, and the red one is going to give us the result in decibels that are the principal unity of this sigma r. And in the part down, we have the difference between the variation of the models that are 18 decibels and 17 decibels. In this part, we're going to talk about the PSRR, that is power supply rejection ratio, that can be explained like Spartans that use shields. It is the same function to protect but the OPAM. In this, we have that they are not perfect. The fluctuation can occur, but this measurement tell us how well the OPAMP rejects those power supply variation and keeps them from affecting the output signal. A higher PSRR indicates better rejection, minimizing output distortion caused by power supply noise. In this part, we have that the formula is in the part down, that is 20 for between log of Bain and Bout and is measured in decibels. We have different unities and results for different versions of the OPAM. In this part, we're going to talk about the power supply range. We can explain it with a light that the green one is the safe operating like range that we have. The safest is in the minimum and the normal voltage. That is 10 and 15. Another is the yellow, that is caution operating, that we can take it from normal to max, and Dadian operating is getting close to 22 voltage that can generate that the OPAM uh, get damaged. In this part, that is the output excursion range, we have that the range of inbound excursion specifies the range of input voltage and op-amp can handle without distortion in the output signal. Exceeding this range can lead to climbing, where the output gets stuck at the maximum of minimum voltage, losing information and creating a water distortion. That can be explained with the get up and down a game that you have in child. That is when we have so much voltage down, we get that the op-amp gets stuck. This is the way what we can explain this part. In this part, that is the maximum output current, we can explain that the maximum output current specifies the highest amount of current on an op-amp that can deliver to load without compromising its performance or damaging itself, thinking of a safety limit to prevent overloading. In this part, we have that the unity or the numbers that we have in the data sheet is 25 milliamperes in all of the models that we have of LM741. In the input exclusion range, we have that specifies the range of input voltage that a pump can handle without distortion its output signal. Is like image the browser checking for exaggerated jumps or dips, and it makes like to be careful to not exceed like a certain limit. The operation temperature specifies the range of ambient temperatures where the OPAM can function reliably. Exceeding the range can damage the OPAMs or affect its performance. Shows an OPAM with an operation temperature range that suits your application environment. This is like how the OPAM is going to function when we expose it to too high temperatures or too low temperatures.